All right, guys, so this is the first part of a series of solving logarithms and exponential videos, okay? So we're going to break it down by how different methods and how you're going to solve these equations, okay? So the first methods we're going to talk about is when you have to evaluate or you have to convert, okay? So up here, it talks about solving. It says when a variable is attached to the log. So basically when the variable is inside the log, see, look at example A, see how the variable is inside the log? When the variable is inside log, then that means you have to convert it to an exponential to solve it. So let's do A. Converting means to do your method. We're going to say 2 to the fourth equals 2x plus 1. So 2 to the fourth equals 2x plus 1. Well, we know what 2 to the fourth is. And if you don't, you can use Desmos in your calculator. 2 to the fourth is 16. That equals 2x plus 1. Now we're down to a linear equation and solving for x. Subtract 1, subtract 1. We got 15 equals 2x. We're going to divide by that 2. And x is going to be 7.5. Okay? All right. So that's when your x is inside of your log, okay? Now, the next one is when you use when a base is raised to an unknown and equals a number. So when your exponent is when your exponentials is raised to a variable, then you also have to convert, okay? So if you look over here at C, do you see how x is your exponent? If you have a variable as an exponent, you have to convert. So I've got to convert this to log. So we're going to convert this to log. Okay. And now it's going to be log base 5. Bring the 32 over here. Put the x minus 2 over there. Remember, if there is no variable, you can evaluate it. Remember we learned about evaluating? You'll go to Desmos. Okay, I've already showed you how to do that. You can go to Desmos and it's going to help you evaluate it. All right, so log base 5 of 32, it gives you 2.15338. That equals x minus 2. All right, and then I'm going to add the 2. So x equals 4.1534. Okay? All right, so let's do another converting one, okay, before we get to the evaluating ones. All right, so if you look here, my x is inside my log, okay? So I've got to convert, okay? So it's just like if you think about your please excuse my dear Aunt Sally, like you can't touch anything inside this parentheses unless you get rid of the stuff on the outside, okay? And I can't get rid of the stuff on the outside until I convert. So it's going to be 4 to the third equals 17x minus 4. Well, 4 to the third gives me 64. I'm going to add the 4. I get 68 equals 17x. 68 divided by 17 gives me 4. Okay, so x here equals 4. And guys, remember, you can always check your answers by plugging this 4 into x and seeing if it gives you 3. Okay, all right, look here. X is the exponent. When x is the exponent, you have to convert it. So remember, to convert it to log, 3 is my base. Bring the 12 over here, and then the x plus 6 goes to the other side. I can evaluate what log base 3 of 12 is, and that's going to give me 2.2619. That equals x plus 6. Subtract that 6, and I get negative 3.738 equals x. Okay? All right, let's see if there's any more up here. Yep, there are more. Let's do them. All right, so, whoops. This one, my x is my exponent. Now, we talked about this. Before you can convert, the exponential has to be by itself. So the base and the exponent have to be by itself. You see this 2 right here? We have to get rid of that 2 by dividing it out. Okay, so now it's going to be 4 to the x equals 7. Now I can convert it. So now it's going to be log base 4 of 7 is equal to x. Type the log base 4 of 7 into Desmos, and you'll get 1.4037 equals x, because x is already by itself. Okay? That's the same thing with logs. So if you look at h, if there was a 2 in front of this log, I would have to divide it out. Okay? Log and the exponential have to be by itself before you can convert it to a different form. Okay? Now on h has no base. Remember I told you when log does not have a base, it is a base of 10. So I'm going to write a 10 right there. Let's write it so you can see it. So it's going to be 10 to the second power equals 2x minus 5. 10 to the second power equals 2x minus 5. Well, 10 squared, that's 100. I'm going to add the 5, and I get 105 is equal to 2x. And then we're going to divide by 2, and I get x to equal 52.5. Okay? So those are the ones that you'll see that are converting. Now let's look at the ones that are more evaluating. Okay? So another one up here says so you use a constant. You use when a constant is attached to the logarithm. So when your log equals x, we're going to evaluate. So let's look at f, okay? So if you look, x is over here by itself. So the log is equaling x. So that means I'm going to evaluate this log and then solve for x. So we're going to type the log into Desmos, okay? So log base 2 of 16, I know that one, but just have it. So 4 equals x squared. Well, how do you get rid of x squared? You square root it. So I'm going to square root 4. Now, here is where you might get it wrong. X squared means you have 2 answers. The square root of 4 is positive 2 and it is negative 2. It gets y'all every time. Y'all forget that second number. If it is a squared, there should be 2 answers. Okay? All right. Look at I. See how it's equaling the x over here? That means we're going to evaluate this. So I'm going to evaluate this log. I'm going to say log of 5, log base 5 of 10 is going to be 1.4307. And guys, y'all are going to be getting a lot of decimals, so just go ahead and get used to dealing with the decimals here. I know they freak you out a little bit sometimes. So we're going to subtract that 6. We get negative 4.569 is equal to x. Okay? All right, so that's the examples for evaluating. One last one for this video, okay? This one's everybody's favorite because stuff cancels out, okay? So when you see how you have 2 logs equaling each other? So use when one log is equal to one another, that does not make sense, is equal to another one log. Logs must have the same base in order to cancel. So if you have a single log on one side and you have a single log on another side, those logs cancel out and you set the insides equal to each other. Okay? So when I scroll down here, if you look here, see how I have log to the 4th equals log to the 4th. They're both by themselves, okay? That's what I'm talking about, singular. Like it can't have like a +3 over here, okay? Everything has to be inside the log, all right? We can cancel these logs out, and I can say 3x minus 1 is equal to 2x plus 3, okay? And solve like you did in Math 1. I always subtract my smaller x's because I don't like dealing with negative numbers. Then I'm going to add the 1. And I get x to equal 4. Again, you can check your answers, okay? Now, when you check your answers with this one, I want to talk about this. You cannot take the log of a negative number. So if I plugged this 4 back in, 3 times 4 minus 1, that's going to be 11. If that had been a negative 11, this would have been undefined, okay? You cannot take the log of a negative number. Okay? And if you check your work, your calculator or Desmos will probably be like, undefined, undefined, ah. All right? So make sure you pay attention to that. Okay? So just check to see if it makes it negative. All right, last one we're going to do. Do you see how they both have the same singular log on both sides? They cancel out, and we're going to set their insides equal to each other. All right, and we'll subtract x. I get negative 6 is equal to x plus 2. I'm going to subtract the 2, and I get negative 8 is equal to x. Okay, now negative 8 I would check, all right, because it's a negative number, okay? So if you get a negative number, I would definitely check it. So let's plug negative 8 in. Well, negative 8 minus 6, that's going to give you negative 14. You cannot take the log of a negative number. So this is not a solution, and instead we're going to put no solution. Okay? It is no solution if the inside is a negative number. And if you go to Desmos, let's go to Desmos. I know your calculator gives you an error. All right, so if I type that in, if I was checking my work, okay, I was using Desmos because I'm at home. I'm going to check my work. We pull up the log function. It was a log base 4. So log base 4. And then we plugged in the negative 8, and then it was minus 6. Looky there. It says undefined, which means no solution. You can put undefined too. I think our Delta Math does undefined. So Desmos even lets you know that it doesn't work, okay? So moral of the story is you cannot take the log of a negative number. All right, negatives always causes some problems, isn't it? All right, so that's it for this part of solving. I'll catch you back later on our next part.